This is problem 1620, and this is a pretty theoretical problem. It assumes away a lot of things that would be present in the real world, like taxes and transaction costs and psychology of investors. So this is purely a theoretical calculation. And it's explained pretty well on pages 418 and 4118 through pages 418 through 419 of the textbook. And so just to get the right answer, you could just take the formulas from the textbook and insert these values. But let's talk about the idea here, which I think is more important. So the idea is that a business or investment is worth what the future cash flow stream is, discounted back to present value, the present value of the future cash flow stream. That's what any investment's worth. In this first case, the simpler case, that where the company is going to pay out $20 per share, it's going to grow by 5% a share, and there's no share repurchases, then you can use the perpetuity growth formula, which is the present value of a stream of cash flows, and I'll put subscript 1 here, is equal to the cash flow. In this case, cash flow is a dividend, so we'll abbreviate that DIV, divided by R minus G, which R is the discount rate and G is the growth rate in this cash flow. This problem's a little bit tricky. I'm almost wondering if there's a simpler way to do it, because I don't know that the textbook has explained how to do the algebra here, because they don't give you any discount rate in the problem that I see. But under this base case, you've got the present value, it's $140 per share. The dividend's $20 per share, and the dividend's growing at 5% a year. So you can just do a little algebra here. Say 140 equals 20 divided by R minus G. As a matter of fact, we know what G is. That's 0.05. And so if you do the algebra on that, you'll get R is equal to 0.1929, if I've done my math correctly. So we can test that that works by plugging in 20.1929 minus 0.05, so that's the R we just calculated from algebra and the 5% growth rate. And there's probably going to be some rounding error here, but so 0.1929 minus 0.05 gives you 0.1429 divided by 20. And yeah, that gives you pretty close to $140 per share. So that checks. So now what about if the company devotes half the cash flow to repurchasing shares rather than paying it out? Well, that's going to have two effects. One, of course, the dividend is going to drop by half from $20 per share to $10 a share in year 0, or it's growing 5% a year, so the next year it would be $10.50 because it was grown by 5%. So that's bad. Dividends cut by half. But each year you're going to be reducing the number of shares. So that same, although the total amount of dividend will still be growing at 5% per year, but the number of shares will also be declining by a rate, which we'll calculate shortly. So the G here will be more than 5% because the number of shares is dropping, and so you're dividing the dividend amount by an ever smaller number of shares. Therefore, that gives additional growth beyond the 5% per year to the dividend per share, not total dollars, but per share. So let's put some numbers to that. So we know the new dividend, so I'll call it dividend 2 here. And it's gonna be $10.50. So I'm assuming this is at time 0, and so the next dividend's a year later, so it's 5% later. That's an assumption I'm making. So right now, the value per share is $140. So $10.50 per share divided by a value of 140 per share means you're repurchasing 7.14% or 0.0714 of the shares each year. So there's an important sort of subtle assumption here. This is, we calculated it for the first year, but we're assuming every year that's going to be the same amount. And you could go through some math to prove that, but I think it's safe just to say, make that assumption now. So every year, the share base is going to be reduced by 7.14%, plus this dividend, although it's been reduced by half, it's still, the total amount of cash flow the company has is still growing by 5% a year. So the new G is this 0.0714 plus the 5%. So that gives you 0.1214 equals G2, I'll call it. So that's the new growth rate in dividend. So what's the value? Let's just start it out here. $10, I'm going to assume, because the dividend's been cut in half. And I'm going to assume the R is still the 0.1929. But the big difference here is this new G, much higher G. So you're making the denominator smaller, and since you're dividing, that means the total value is going to be greater. So if you plug all these numbers into your calculator, voila, you get, because of rounding it's a few cents off, but you get the $140 per share, which I'll call PV2 again. Sorry, I should move that up. So $10 divided by the same R, same discount rate, but subtracting the new growth rate gives you the same $140 per share using this perpetuity growth model. You could probably you should be able to do the same thing using a spreadsheet and carrying it out 50 or 100 years, some very long period of time. But the textbook described this method on pages 418 and 419, so I'm thinking that's the approach they want you to take with it. If you want to do some further study on this, which I doubt you do, but if you did, you'd want to convince yourself about why the share base decreases by this amount every year in the future, not just the first year. Okay, that's all.